Hello folks, Tim Beavers here, CFII down at Monroe Executive Airport, KEQY. And I'd like to go over a simple flight plan from Monroe to Columbus County, CPC, down just south of Whitesville. So what I did is I picked a fork in the road by Highway 601 and 74, which a lot of Monroe locals know, just southeast of Monroe as the initial starting point. There's Monroe Executive. And we'll head down to a railroad bridge just near the town of Chiraw. Then further south down to a road bridge that's just northeast of Darlington. And then on to a small town called Lakeview, which should have a 90-foot water tower just to the west of it, hopefully visible, not sure. And then on to the Columbus County Airport, KCPC. All right, so there's a lot to cross-country planning, and I'm just going to try to make this video as short as possible with just the nuts and bolts of getting a flight plan together from scratch and putting in all the relevant data. So what has already happened in this video is some of the pre-flight planning, the altitude that you've chosen, the winds, turbulence, weather, icing, etc. So all the pre-flight planning as far as choosing altitudes and stuff like that has already occurred. However, having said that, we do need to take a look at the cruise performance. And all the data here is going to be for a Cessna 172 hotel model, 1967, since that's pretty much my bird. So we're going to use this data, but obviously your POH will be separate. So we chose 5,000 feet. You can talk to your CFI, the pros and cons of choosing different altitudes. But in this instance, we have a couple of things that we'd probably like to add. First off, this is in true airspeed, miles per hour, so we're going to want to change that. We have a gallons per hour book rate, and that's easy to change to gallons per minute, which is actually a pretty nice number to have, and I'll explain that later. Hopefully I'll get to that. And then lastly, you actually can get a little bit of an efficiency rating, more or less, and it's not exact because obviously you have winds and stuff, but you can actually get, cars have a miles per gallon efficiency. Well, the data is right here to get a nautical miles per gallon efficiency based off of the true airspeed in gallons per hour. So, and I'll show you how to do that in a second. Okay, so first off, true airspeed is to go from knots to nautical miles. From knots to statute miles, I need to multiply by 1.15. So to go from statute miles to nautical miles, you need to divide by 1.15. So in this case, divide 124 miles per hour true airspeed, divided by 1.15. Comes up with about 108 knots, okay? So we can actually write that in here, and that's not a bad idea. 108 knots true, okay? 7.9 gallons per hour, what is that per minute? So we did basically divide by 60 to get gallons per hour to gallons per minute. Divided by 60 equals 0.13. And that's pretty close, 0.132 if you really want to be gnat's assing it, but I can't say that, but I just did. So anyway, 0.13. And then what is our efficiency? Well, nautical miles per gallon, it's pretty easy. So we have nautical miles per gallon. We have a speed, which is in 1 hour, we will travel 108 nautical miles. In 1 hour, we'll travel 108 nautical miles, and we will burn 7.9 gallons, right? So this is all based off of 1 hour. So in 1 hour, we do that. We travel that far and burn that much gas in 1 hour. So it's the efficiency in a nautical miles per gallon kind of car sense is simply 108 divided by 7.9. And that's just a kind of a nice number to have, 13.67. And what you can do is go down, and for every number here on this on this choice chart, you can actually see how more or less efficient the stuff gets. So let's take the one right above, 127 divided by 1.15 to get knots is 110 knots, and then divide that by 8.4 gallons is 13.15. So we're getting 13.15 miles for each gallon as we go get faster. And obviously, if you go in this direction, down slower, you'll end up getting more nautical miles per gallon. That's just kind of a little insight into maybe some efficiency numbers. So anyway, we've chosen 2,500 RPM, which is a 70% BHP, and that's at 5,000 feet altitude. You may be up 5,500 feet. We're going to fly, that should give us 108 true, 124 miles per hour with 108 knots true, and burning 7.9 gallons per hour, 0.13 gallons per minute, etc. Okay, so that's what we've chosen for the cruise. Now, for the rate of climb, I tell folks this is kind of like Jello nailed to a wall, but here's some information we can get out of this. Instantaneous rate of climb at 5,000 feet of pressure altitude, which is where we're more or less going to be. If it's going to be a warmer day or a colder day, you can adjust. But our instantaneous rate of climb is 435 feet per minute. Down at sea level, same day, same airplane was 645. So we can kind of rough estimate that we're going to probably climb at about 500 feet per minute conservatively. And we're going to burn to get up to 5,000 feet. We're going to burn 2.6 gallons, which fuel use includes warm-up and takeoff allowance. I believe, since this is the sea level rate, to warm up and take off, it burns 1 gallon. So to get up to 5,000 feet, you're actually going to burn 1.6. Okay, so that can compute into your calculations. 1.6 gallons for the flight up to altitude, and then probably 1 gallon for taxi. So your choice on that. So when we come to the flight plan, now this is the handy dandy Tim Beaver's model flight plan. I made it into a larger piece of paper. The smaller piece of paper is a little tough to work for. Fits great on an e-board, but tough to work on for a class. So we're probably got 39 gallons total, of which 3 is unusable. Taxi out, we're going to say 1 gallon. And we don't know the burn yet, so we're going to fill that in later. The FAR reserves, if we round the cruise data to 8 gallons per hour, that means the minimum FAR reserve of 30 minutes is going to be 4. It's a daytime flight. Let's say we want 2 gallons to go down to Wilmington. And if there's any extra fuel, let's say you have a minimum of, I never want to land with 10, you say to yourself, until I'm more experienced or whatever. So right now we got 3, 7, 8, 9, and you might add 1 extra to say 10 gallons is my minimum landing fuel. And that's just an example, okay? The planned landing fuel, what we're going to do is find the burn and then fill in a planned landing fuel. So we have a min landing fuel and a planned landing fuel, and therein lies a difference of how much gas you can actually carry on board with you. If you don't have full tanks, that would be the difference there, right? Okay, so let's move on. So we've chosen the cruise altitude of 5,000 feet, and we know our time to climb about 10 minutes, and we're going to burn about 1.6 gallons to get up there. Okay, so here we are over at Monroe Executive, and the thing is, and I've got to zoom back out here. So here we are way up here at Monroe Executive, and it turns out that the nautical miles from Monroe Executive to our fork in the road is straight line distance is about 6 nautical miles. But of course, we don't know exactly which route we're going to take to get there. This taking off northeast or southwest. We just know that this is probably going to be about the top of climb. And as far as miles away, you can actually do some quick math. Well, if I'm averaging 500 feet per minute, and I'm going, and my delta in altitude is 5,000 feet, then 500 feet per minute, 5,000 feet, about 10 minutes worth of flying, about 2.6 gallons of gas, or 1.6. So we can actually put that into our flight plan right off the bat. So KEQY, and all this other stuff doesn't matter on this first leg, but the time is going to be 10 minutes, and the burn is going to be 1.6. Okay, and we're planning on, unless if you dip the tanks and you're out there and you have less, you can adjust that. But we're actually going to take off with 38 gallons. Okay, so right off the bat, we know that 36.4 is going to be our totalizer at the top of climb. Okay. Now we look down here. There's 1, 2, 3, and then points, and then the final destination. And so I'll just call that the first fix is the first mistake. The first fix is going to be the fork in the road. Okay. The second fix is going to be the railroad bridge. Third fix is going to be the car bridge. Car bridge, maybe put a little note here by Chiraw, or north of Florence. And the railroad bridge is northeast of Chiraw. And then over here is the town of Lakeview with tower. Okay, Lakeview. And then finally we're landing at KCPC, Columbus County. Okay, so here's our baseline flight plan, okay, so far. Not too complicated. Now, why did I choose these points? Well, and why does it zigzag? Well, it's kind of a little instructor thing. You probably would want to fly straight line distance between one and the other, but in order to fly and get some good points as well as turns, and then maybe different looks of wind, etc. That's why I have a couple extra different points in there. You could also go VOR to VOR. We've got Chesterfield, we've got Florence down here, and then you could go straight to, if you have an NDB, there is an NDB on the field at CPC. So why I zigzag is really just an instructor thing to get different headings and winds and courses and headwind, tailwind, et cetera, as well as the fact that flying this VFR, you're going to have your head out looking for visual references, and it's really tough to. I mean, if you're going to fly direct to a VOR, did I misspeak? If you're flying VFR, you want a nice distinct points that you're going to. And a VOR that's kind of an instrument point, more or less. You're not going to see necessarily the VOR down the field, although you could. Okay, but you're definitely not going to miss this railroad bridge and by the town of Chiraw that you just passed from an airport. And then you're probably not going to miss, because now we're following the PD River right here that we cross over it a few times, and then one final time we get to a car bridge, and then it's going to be a left-hand turn straight to Lakeview. Okay, so that's a little bit of why I picked some of these points. Okay, all right. So now let's fill in the blanks here, and I'll fill in the blanks for at least one, maybe two legs, and fill in the last one, or pick your own points from there. So here we are, from the fork in the road to the railroad bridge. Okay. Now, what's the distance here? Well, we take out our handy-dandy plotter, and one important thing is that you want this to be sectional chart nautical miles, okay? If you're up here sectional chart statute miles, you're in the wrong area, okay? So heads up on that. I know there's different tick marks on the back and the front. I had one plotter that was statute on one side and nautical on the other, and I actually didn't figure that out until my numbers were way off. So definitely, every time you look here, make sure you got sectional chart and nautical miles, okay? Now, also, you look at how I drew this. I drew a circle around the point that I want, and then my line doesn't actually go straight to the point. If I have this big, thick, black line, and it goes over the point, I'm going to miss some detail here on the VFR chart, right? The thick marker is going to blot out some detail. So what I do is I circle the point, and then I connect with a straight line between the 2 points, but I don't go inside of the circle that I drew, okay? If you really want to be retentive about it, you can get a little circle cut out and draw perfect circles, and that's your choice. I also, if you notice, this is all personal preference too. I highlighted the route as we went through. Once again, not highlighting inside the circle for detail reasons and so I can see what I'm flying towards when I get right over it. Okay. All right. So simply put, we put we're sectional chart nautical miles. How far to the Chiraw Bridge? Well, that's about 35 nautical miles, right? So from KEQY to the fork, and now we're at the fork going to the railroad bridge. That's how I read this. So the distance is 35 nautical miles. Now the true course, the true north and south and true east and west are all on these grid lines here. We have an isogonic line coming right here. This is the 8-degree west isogonic line. The 8W is off your map somewhere, but it's here. That's the isogonic line right there for 8 west. Okay, we could actually fill that in as well. For the magnetic variation is going to be 8 west right here. So plus 8. Remember, east is least, west is best, right? So we add a west isogonic line. All right, and talk to your instructor more if you want to brush up on true north versus magnetic north, etc. All right, what is the true course now? So up here we have one other thing we can fill out, the true course. All right, so here's filling out the true course. Now there's a bunch of different plotters out there, but here's how I do it. So I line up my plotter with the line, okay? And now I want to find what north-south grid line is going to be the best for me to use for this, okay? So it looks like if I line up to this north-south grid line and slide it along your route of flight, okay? So now my little, let's say zoom in here, maybe I can see that better. So now the little hole in the plotter is right over that north-south line. So we know this is a, oh, and I bumped it. Yuck, 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 yuck. So we know that this is east, right? So 100, 110. This should be about 110. So what I do is I look and see which line is going to be the one to use, okay? So if my plotter were facing like this, it'd be, there's 90. And as the plotter continues to dip, sure enough, 90, 100, 110. And if I read this, I got 118 is my true course, okay? So we see that there? There's 90, 100, 110, and then 118. So 118 is the true course that we put in here. Okay? Now, we can go and do the next point as well, since we got the plotter out, and get the distance and true course as well again, as well as the magvar. The magnetic variation, the next isogonic line is off the chart a little bit close. Actually, the isogonic line goes right through Columbus County. So we're still at 8 west. So for the next leg, sure enough, that magnetic variation is going to be plus 8. Okay. Now let's follow me along, and we will do the next leg. Okay. In the same manner. Okay, so there's the Chiraw Bridge, and there's the car bridge, and you could do fractions if you want, but it really depends. So this is 22 miles, 22 and a half if you want to be crazy, but I'll just call it 22. So the distance is 22, and then what is the heading? Well, we know that, that's east, there's south, so it's gonna be maybe 150. So it's always good to have a ballpark figure that so you're not like way off, obviously. So this should be around somewhere between 90 and 180, but I'm saying like 150. So that's my guess. It's always good to have kind of like a guess, a gauge, so you're getting close, right? Now in this case, it looks like the easiest grid line is an east-west one. Okay, the other time it was a north-south one, and sometimes you won't have a choice. So we go to the east-west grid line down here. So I'm lined up, and I go to the east-west grid line where the little hole in the plotter is, okay? And so I know that if the plotter were down here, that'd be 180, okay? So it looks like we're on this center line right here, okay? So 180, 170, so we're counting down on this inside wheel here. So 180, 170, 160, 150, so 158 it looks like. And if you want to Nats ass it, you can go 150. Well, it looks like if I go to the outer ring for more detail, it looks like 157 is the course there. And that's the true course, okay, based off of true. So 157. Okay? All right, so you can continue on the last two legs as well. You're not going to have anything on this last leg. Okay, so this last leg is going to have no data because you're landing at here. Okay, you can though put in maybe 1 gallon for approach and landing if you want, and have a final down here. But that's your choice. So I'm going to leave the next two blank. Up here, this is all top of climb stuff, so you're climbing, okay? So this is all top of climb from KEQY to the fork. All right, so now, how exactly to pull up the wind? Well, I would go to the aviationweather.gov /GFA, graphical forecast for aviation, and get the winds. But today I'm just gonna make them up for purposes of training. I'm gonna give you a slight tailwind here, slight left quartering headwind, and then a direct cross on the final one. So from the fork to the railroad bridge, the winds are going to be 330 at 20. Okay. From the railroad bridge to the car bridge, I'm going to make them 080 at 15. Whoops. The winds go down here 080 at 15. Railroad bridge to car bridge. That's too many mistakes. That's why we have a pencil, eraser. Okay, so we got the two winds. The last one, I would vary the winds. Obviously, the winds aren't going to vary that much on a short flight like this. So, but I'm doing this for a training. All right, so the way the flight plan works, okay, so we've got a true course. We're going to get a wind correction angle from that, as well as ground speed when we do the wind computer, okay? And that gives us a true heading. From the true heading, we can get a magnetic heading by changing the magnetic variation. And then we'll look at our compass card in our airplane and change the compass heading specifically from that point on. By the way, if you wanted to copy the flight plan right here minus the winds, well, the distance in the true course and the mag var are probably not going to change, okay? So you could take this flight plan, if you're going to fly it a few times, and copy some of the basic data, and then when you actually go out, the stuff that's not going to change, and when you actually go out to fly it, you'll put in the other stuff, the winds. Okay, all right, so let's do our little thing here. And also up here in the top, the cruise altitude was 5,000 feet. Okay, the RPM was 2,500. The knots true was 108 nautical miles per hour. Knots true, and then the gallons per hour was 7.9, and the gallons per minute was 0.13. Okay, and that's once again, I'll show you that hopefully here if we have time. Okay, so now we need to find the true heading with the wind correction angle. Okay, so here's how the E6B works. It's basically vector addition. It's mechanically adding vectors, which I think is brilliant, whoever came up with this. So we're going to look at this E6B here, and I'm going to try to zoom in. Okay, so the first thing I'm going to do is make my heading component. So 330 at 20 knots. So we got the true index up at the top. It says, so we're going to find 330. Okay, and we need to put a 20 knot wind component. So the easiest way to do that is just put your circle on 100 and then go 10 and 20. Now I use pencil and just lightly draw in, not too hard, but there is my wind component vector. Okay, so, and it's actually, the tail is the X of this wind component vector, and the head of the vector is the circle, because the circle is where you're going to end up. Okay, so now we take, what was our true course was 118, okay? So we'll head on over to 118. And sure enough, if we look at the E6B, that's 118's giving us a left quartering tailwind. So 110, 118 right up here. You see we got 118 on our true index, okay? Now the next thing we need to do is our speed, our true airspeed is 108 knots. So we need to put the tip of our vector. Our vector starts down here and goes to 108 knots. So we're going to put the 108 knot line. Okay, there's I'm doing this by looking at it and as well as looking at the screen at the same time. 100, there's 110, so 108, 2, 4, 6, 8. Okay, so this is our vector, and we're adding the wind component vector. So here is the resultant vector. Okay, the result of adding the our velocity vector as well as a wind velocity vector. Okay, so we get a wind correction angle, and this is left is subtract. So it's if you're going further to the left, it's minus. Okay, so there's 10 degrees. So 2, 4, 6. It looks like minus 6 degrees. Okay, and here's where we put down our wind correction angle, minus 6. And while we have this up here, we also want to get the ground speed. Okay, so the ground speed is way up here. Our resultant ground speed is 110, 120, 123, it looks like. Okay, so now on the flight plan, we'll go over here and get our ground speed of 123, I said, 123, okay? All right, now the rest of the heading thing is actually pretty easy. It's just adding, right? So 118 minus 6 means our true heading is 112, okay? Now the mag, but we work off a mag, not true on the airplane, right? Because it's off of compass heading. So now we add 8 for the mag variation, and we get 120, okay? And the last step in the mag puzzle is a compass card. So we have a compass card here from 2866 Lima. And sure enough, if the heading is around 120, we have to add 1. For 120, we need to steer 121, so it's a +1. So the compass card correction is +1. So our final compass heading is 121 degrees, okay? All right, so now we have a ground speed. Now we can get the leg time. The derivation of these formulas is actually pretty easy, but I'm going to skip it right now. But basically, the leg time is 60 divided by ground speed times the distance, okay? Now, understanding where they come from is, I think, really important. Just so you can kind of get a gist of where what the numbers are telling you, not just plugging them in. But I don't have time to go into the gory detail. Maybe save that for another class. So 60 divided by the ground speed, which was 123. Okay, I'm trying to put the calculator up here. Okay, divided by ground speed is 123. And then times the distance, which was 35 miles. Okay, so the leg time is 17.1. Okay, now you can do tenths of a minute. It's actually not a bad thing to do tenths of a minute, because every tenth of a minute is 6 seconds, and you can just add that up later. Or you can round down and just do whole minutes. It's really personal preference, depending on what you and your instructor want. You know, rounding to the nearest minute is fine, but realize that you're burning like 1/10 of a gallon for every minute. So if you have a bunch of rounding errors, it could possibly be significant over a long flight. But in any event, so 17.1 is our leg time down to the Chirral Railroad Bridge. So our total time crossing the Chirral Railroad Bridge should be this plus that, 27.1. Now what about our fuel? Okay, so in the same manner, leg fuel is gallons per hour divided by ground speed times distance. So the gallons per hour, 7.9, divided by our ground speed of 123 times 35 miles. So the burn going down there is 2.25. So we'll just call it 2.2, okay? A burn of 2.2 gallons. And you could round, on the numbers for the gallons, you can round up or the nearest decimal. I'll do nearest decimal because each tenth of a gallon is a couple minutes. So nearest decimal is fine for me, but once again, let your instructor guide you on that. Because there is, at some point, being too accurate is a lost cause on a Cessna 172, right? But so the final fuel then is going to be 34.2, okay? So we have a total elapsed time, and then what we do is add up our leg times to get elapsed as we go along, and our burn is going to subtract from our takeoff fuel all the way down, okay? All right, so real quick, I'll do the next leg, and you can follow along without all the gory talking. Okay, and this should go real quick. All right, so basically I'm going to do the wind component. And once again, I gave myself a 080 at 15, so guess what? We need to put the 080 at 15 on our handy dandy computer. So go to 080 on the true index, 080 true, and then there's 100, there's 10, and there's 15 knots right there. Okay, so that's 080 at 15. Our true course that we're actually going to fly is 157. So let's put 157 in here. So there's 157. Sure enough, it's a left quartering slight headwind. Okay, almost a direct cross, but slight headwind. So now we need to put, we're doing, remember our true airspeed was 108 true. So let's put the tip of our vector on 108. And sure enough, as what one might expect, there's the tip of our vector at 108, so it's 8 degrees left crossing angle, and we actually lost a little bit of speed. We're actually at 112, let's see, no, 102 knots, I'm sorry, 102. Okay, so let me put that up on 108. Yeah, we'll call it, all right, so yeah, accuracy is good. So there's 108, and the tip of our velocity vector is where the tail of the wind component vector is. So sure enough, our crossing is 2, 4, 6, 8, is left 8, a minus 8 degrees, and our resultant ground speed is 104. So we lost a little bit there. So 104 goes in the resulting ground speed, minus 8 is our wind correction angle. This all works out. 157 minus 8 is 149. Then plus 8 again is 157. All right, and then for the compass card, if we're heading south more or less, there is no correction. Okay, 50 and 180, there is no correction. So that's 0. So 157 is our compass heading. And now we'll get the burn and the leg time. Okay, so leg time is, let me move this over a little bit. So leg time is 60 times, well, distance, which was, the distance was 22, okay, in this case. So times 22, and then divided by the ground speed, which we said was 104, equals 12.7 minutes, 12.7 minutes, okay? So add these up. 39.8 minutes so far in the flight to get to the car bridge, right from the railroad bridge to the car bridge. And now for the fuel burn, we're gonna see how much fuel we burned on that leg, okay? And see, the key is once you do have the ground speed, and you already chose your book burn rate, so with the ground speed, the rest of it's just quick math. So the gallons per hour was 7.9 divided by ground speed of 10, and memory is failing, 104. Oops, crap. Okay, gallons per hour, 7.9 divided by 104 times the distance of 22. And we get 1.7 gallons. Okay, and that makes sense. You know, it's rough sense numbers, right? You know, the winds are going to affect us a little more than in a faster airplane, but yeah, it's a shorter leg, right? 35 versus 22 miles, so yeah, it's shorter time, and the burn's less. So yeah, I mean, if you have some severe wind shifts, it might be different, but these are all making sense, right? Do a little common sense check every once in a while. That can't hurt. So we'll do 33 is 12.5, and then 32.5 is what we end up with. Okay. All right. So that's pretty much it. You can finish out the last couple legs. There are many techniques for descending on into a field, so I'm not going to belabor that too much, but I do have some notes here. You know, when do you want to be at pattern altitude? what's your descent rate going to be, what's your ground speed plan going to be. Now, obviously your winds change. They probably are less as you descend down, but what's your top of descent going to be at 500 feet per minute, assuming 2 miles a minute, etc. So 120 ground on a descent at 500 feet per minute. So good way to calculate all that stuff. Other stuff that can go on the map are emergency divert fields that are within your glide range, which may change, and it's actually different depending on what your wind component is. There's other things that you could put on the map. For instance, where do we cross certain power lines? Here's a nice check where we're crossing a power line, a set of power lines. You can figure out how many miles is that. To cross that set of power lines is 8 minutes, and at the ground speed we're planning on flying at, how far is that? When should I cross, etc. So some feel good, get well points. If you want to do nav aids, you could do a beam Chesterfield. So just put this at the 90 line, and just doing a beam Chesterfield. So there's at the 90 line, and a beam Chesterfield is right here. So that's where this course dialed in is going to change from to from, or you can take that's 0, 5, 10, 15, 20, 25, 30. If you dialed in 030 off of Chesterfield, you should be crossing that point at the 030 mark. So your course deflection on this Chesterfield would switch from one side to the other, and you'd also go from to from if you had if it was based off of that course. That's other instrument stuff your instructor can go over with you. But anyway, some feel good points there. Also down here, you may notice that for this leg here, we crossed the PD River numerous times, so those might all be feel good points for you. We cross it once right here. And we cross it, it stays on our right-hand side, and then there's a little nub that goes on our left-hand side from here to here. And those are all mileages and times that are all relevant to you. And then we cross another, just before we get to the car bridge is another big bend in the PD River you see right there. So those are all good GeoRef points for feel good, as well as showing that whether you're on or off course, right? So as you fly this, you could probably make out the river goes off to your right, bends around, and comes in, and then goes north for a little bit. Well, right where it goes north, right in the center line, is where it goes north, and that should be where you're crossing. So you could actually look at that. And here, the river does a really sharp bend. Well, just before it does that, you'll be on the elbow of the just before it does that point. So, and about a minute or two away from the field. So, from that fix, the car bridge. So those are also good feel good points to let you know how close you are to course. Other neat stuff. If there is visual references in a Cessna, this makes a difference. You probably want them off to your left-hand side, probably, with some exceptions, but probably want them off to your left-hand side. And down here, there's just of note, there's a large double tower right there, lighted. So that's other stuff to know. What I do with my maps is I take them and I basically tear them up. This map, instead of this huge chart, I basically ripped, just like I would have in the Air Force, but I ripped it down to a manageable size. So I don't have this all folded just so I can lay flat, but if I'm really doing this flight plan, that's why I have all these words in the direction of where I would have it on my knee board. So I'd probably have my knee, as I'm flying along, and on my probably my right knee. Left knee is for writing stuff down, okay? And as we fly this, and the left knee would have, or the right knee would have this map folded up, and then if I fold it right, I would only have like one fold, and then flip it over for the last half of the leg, the last two parts of the flight. Other things, when you actually do fly this and you come to a score, let's say you're 1 minute early, or let's say you're something happened with the winds and you're 5 minutes late, right? Well, here's where the gallons per hour kind of comes in handy, or gallons per minute, all right? Kind of comes in handy. Let's say you're 5 minutes late, you had to do a 360 for some reason, who knows why, or you had to avoid a TFR or something like that. So you're 5 minutes late coming in. Well, you can just do a quick burn check on that. At 0.13 gallons per minute, 5 minutes late, you burned about a half gallon. So that might be something that you'd want to add and factor into down here with your burn rates and stuff. So, and that's because this is all planned, right? We've sat in a room, we planned all this, but when we actually get there, if this leg, instead of 17.1 minutes, actually took 22.1 minutes, it's not burning 2.2, it's burning 2.6, yeah, probably 2.6, 2.7, right? So that's where you can come up with your own method of doing that, but maybe cross out. We can use the score right here, the plus or minus minutes, and then there's another, right here could be your burn, plus or minus. There's your plus or minus time, there's your plus or minus burn, okay? A bunch of ways to skin the cat. So that's pretty much it. There's more stuff to talk about on this flight plan, but not that I want to bore you with, but those are the basics about flying. So to summarize, what we're doing is we're getting a distance, true course, and the magnetic variation with our plotter and map. From aviationweather.gov, we're getting winds, okay? And we could get winds for the midpoint of each leg and write it in right here. And then from there, we're using our E6B or some other planning calculator to get the wind correction angle, get a true course, add or subtract your magnetic variation, get a magnetic heading, and then add or subtract things from your particular airplane compass card, gave your compass heading. We got the ground speed from when we did our wind calculations. With the ground speed, we can get leg time and leg fuel, and lather, rinse, and repeat for each leg. And with a little bit of practice, this can be done quite quickly. So with that, I appreciate your time, and hope flying around executive. So if you see me up in the air or down at the office, be sure to say hi. Love to chat. In any event, Tim Beavers, that's it. And call me, well, not call me, but email if you have any questions, or leave comments, remarks, etc. down at the bottom. Appreciate it. Have a good one.